Hello, Kurt here, and today we're going to talk about the divisibility rule. Our main objective here is to define whether a given number is divisible by the first 12 numbers on the set of counting numbers, which are 1, 2, 3, 4, all the way up to 12. But before that, let's talk about the word divisible. A given number is divisible by another number if and only if there is zero remainder when we do our normal division method. Let's have an example. 124 divided by 4. 12 divided by 4 is 3. 3 times 4 is 12. Subtract. And then bring down 4, we'll have 4. Then divided by 4, that's 1. Multiply by 4, we'll have 4. And then subtract. As you can see, the remainder we get is 0. So, we can say that 124 is divisible by 4. Unlike 125, if it is to be divided by 4, then the remainder we'll get would be 1, hence not making the number 125 divisible by 4. Let's start with divisibility rule 1. All counting numbers are divisible by 1. And when we say counting numbers, that ranges from 1 to positive infinity. But how can we say that all counting numbers are divisible by 1? Well, for a certain, all counting numbers are multiples of 1. For example, 10 is a multiple of 1 because that would be 10 multiplied by 1, meaning we'll need 10 ones to reach 10. So, 10 is divisible by 1. Divisibility rule 2. A certain number is divisible by 2 if and only if the number is even. But how are we going to determine that? Simple, just by looking at the ones digit. If the ones digit of a number is either 0, 2, 4, 6, or 8, then we can say that the number is divisible by 2. Let's have this as an example. 6,980. The ones digit is 0, of which makes 6,980 an even number. So, 6,980 is divisible by 2. Let's have another one. 4,593. The ones digit is 3, which is not an even number. So, the number 4,593 is not an even number as well, making the number 4,593 not divisible by 2. Divisibility rule 3. A certain number is divisible by 3 if and only if the sum of the digits are a multiple of 3. For a much better way to understand this, let's have an example. 582. The digits in this number are 5, 8, and 2. For us to determine if it is divisible by 3, let's compute for the sum of its digits first. 5 plus 8 is equal to 13. 13 plus 2 is equal to 15. Now that we have 15 as the sum, let's determine if it is a multiple of 3 as well. Well, we all know that 15 is just 5 3's or 5 times 3, of which makes 15 a multiple of 3. Hence, 582 is divisible by 3. Divisibility rule 4. A certain number is divisible by 4 if and only if the number formed by the tens and ones digits are multiples of 4. For example, 680. The number formed by the tens and ones digit is 80. Now, let's determine if 80 is a multiple of 4. For certain, it is because 24's or 20 times 4 is equal to 80. Hence, 680 is divisible by 4. Let's try another one, 469. The number formed by the tens and ones digits is 69. Now let's determine if 69 is a multiple of 4. If we divide 69 by 4, we'll get a remainder of 1. Let's try. 6 divided by 4 is 1, multiplied by 4, that's 4. 6 minus 4 is 2, bring down 9. Now 29 divided by 4 is 7. Multiplied by 4 it's 28. subtract and then the remainder is 1. Since the remainder is not 0, the number 469 is not divisible by 4. Divisibility Rule 5. If a number has ones digit that is either 0 or 5, then the number is divisible by 5. Let's try multiple examples. 459, 710, and 325. Which of these numbers are divisible by 5? Well, let's look at the ones digit of the three numbers. 459. The ones digit is 9. 710. The ones digit is 0. 325. The ones digit is 5. Since the condition is to have 0 or 5 as the number on the ones digit, then 710 and 325 satisfy the condition. Then 710 and 325 are the only ones in the example which are divisible by 5. Divisibility Rule 6. If a certain number is divisible by 2 and 3 as well, from that we can only say that the number is divisible by 6. Let's have an example. 282 is divisible by 2 since it is an even number. Remember, the ones digit is an even number which is 2, so the number 282 itself is as well an even number. Also, the digits in 282 are 2, 8, and 2. Taking the sum of 2, 8, and 2 will get 12. Now, is 12 a multiple of 3? Of course. 4 threes or 4 times 3 is 12. So, the number 282 is divisible by 2 and 3. And since that is the case, the number as well is divisible by 6. Divisibility Rule 7. Given a number, let's cross off the ones digit. Then, we'll double it and subtract it with the remaining digit of the number. If the remainder is either 0, 7, or a multiple of 7, then the number itself is a multiple of 7. Let's have an example. 392. The ones digit is 2. We'll cross it off and then double it. That's 4. Now, since we cross off 2 from 392, we're left with 39. Then, let's take 4 and subtract it from 39. We'll get 35. Now, determine if the difference is a multiple of 7. Well, for certain, 7 times 5 or 7 fives is 35, making it a multiple of 7. So, the number 392 itself is divisible by 7. Note, you may repeat this process from the top if the remainder is still too large to determine if it is a multiple of 7. So, with the difference of 35 from our number 392, take the ones digit again, then double it. Well, if we take 5 and then we double it, that gives us 10. 10 minus 3 is 7, which satisfies the divisibility rule of 7. Then, the number is divisible by 7. Divisibility Rule 8. A given number is divisible by 8 if and only if the number formed by the hundreds, tens, and ones digit is a multiple of 8. Let's have an example. 7,640. The number formed by the hundreds, tens, and ones digit is 640. Now, let's determine if we will acquire 0 as a remainder if we divide 640 by 8. 64 divided by 8 is 8. 8 multiplied by 8, that's 64. Subtract and then we'll get 0. Bring down the 0 and then we'll have 0 divided by 8. That's 0. 0 multiplied by 8 is 0 as well. then we'll have the remainder 0. Since 640 is divisible by 8, then 7640 is divisible by 8 as well. Divisibility rule 9. A certain number is divisible by 9 if and only if the sum of the digits is a multiple of 9. Pretty much like on our divisibility rule on number 3. For example, let's take 9684. The digits are 9, 6, 8, and 4. The sum of the digits here are 27. Since 27 is a multiple of 9, which is 3 nines or 3 times 9, we can say that the number 9684 is divisible by 9. Divisibility rule 10. As simple as the divisibility rule of 5, if a number has a ones digit that is 0, then the number is divisible by 10. So in the examples 27,908, 62,380, and 682,947, well, 62,380 is the only number with 0 as its ones digit, then it makes the number divisible by 10. Divisibility rule 11. Let's take the ones digit and cross it off and subtract it with the remaining number. If the remainder is either 0, 11, or a multiple of 11, then the number is divisible by 11. Let's have an example. 1221. The ones digit is 1, and then we're going to subtract it from 122. We'll get 121. Now, let's determine if 121 is a multiple of 11. For certain, 11 times 11 is 121. Hence, the number 1221 is divisible by 11. Note, we could still repeat the process if the remainder is still too large to determine if it is a multiple of 11. Just like 121, the ones digit is 1. Subtract it from 12, we'll get 11. Since 11 is the remainder, the condition is satisfied. Hence, 1221 is divisible by 11.
Divisibility rule 12. A given number is divisible by 12 if and only if the number is divisible by 3 and 4. Recalling it, a number is divisible by 3 if and only if the sum of the digits of the number is a multiple of 3. Also, a number is divisible by 4 if and only if the number formed by the tens and ones digit is a multiple of 4. Let's have 62,820 as an example. First, let's find out if the number is divisible by 3. The digits of the number are 6, 2, 8, 2, and 0. The sum of these digits are 18. 18 is a multiple of 3, which is 6 threes or 6 times 3. Therefore, the number 62,820 is divisible by 3. Then, let's determine if the number is divisible by 4. The number formed by the tens and ones digit is 20. 20 is a multiple of 4, which is 5 times 4 or 5 fours. Therefore, the number 62,820 is divisible by 4. Both conditions are satisfied, therefore, 62,820 is divisible by 12.